Okay, thank you for informing me. Okay, let's continue. Already started.
Doctor,
Yes.
sorry for interrupt.
Yeah.
May you share the slide in the email?
I didn't share module 3.
I think not yet.
Okay, let me do first so then you can compare and you can fill in important information. Okay, I share first in the WhatsApp so it's easier. Later on I will upload to your e-learning. Okay, please check your e-learning. I already share the module 03. You see? Okay, let's start on assembly language. Okay, this is the very basic language programming that you can learn. By learning assembly language, you have the basic knowledge how to learn later on for C programming and higher programming language later on, Java, Python, and so on. And assembly language is the oldest programming because it is a basic language, right? And if you compare to other language, and this assembly language is most close to our native machine language. Your computer only know your machine language. So machine language, it is not like our sentences of all other programming language you use like move, AX, EAX, and so on. So this one is normally our programmer will understand. But machine language, human normally not understand because it is on numerical language 01, 01, 01, and etc. And it understood by computer processor, which is your CPU, your machine only. While for assembly language, provide direct access to computer hardware, which is requiring us to understand about our computer architecture and operating system. This semester you learn on COA. Next, I think next semester or another one semester you're going to learn on operating system. So each assembly language instruction will be correspond to a single machine language instruction. So before you can play around with your programming, which is with your Visual Studio, okay, you need to know the basic on theory. What is, or let's say you have .cod saya 100H kamu 2H or might be 101B 123H, and then you have dot data here, dot code. So all of this you need to know, and at the beginning you're going to have a command. So before you can write your programming, you need to know the basic architecture, where you're going to apply the integer constant when you have the value of integer constant, let's say you have 7 as the integer constant, you want to put and apply into your program. Okay, how you can apply? Real number, constant, characteristic, and string before you can put into your programming. Similar also the rest, the instruction, how you're going to play around with instruction. Normally might be you want to do the, sorry, this one is directive. Okay, directive. And then instruction, maybe you want to do additions of two numbers. So how you going to apply it in the instruction? Comment, how you going to comment? This one is good for programmer. Sometimes lazy person don't want to put comment, but it's good for programmer to have comment, so then you know, let's say for this line, for this line 7, what is the functions of line 7? Or maybe after you finish doing a programming, at the end you're going to put your comment version 1. Whenever you edit, you click version 2 and you put the date and so on. So it's easy for you later on to check what is the progress of your programming. That's why you need to learn all the theory and how you're going to apply. Later, you're going to look also on addition, subtraction, defining the data, symbolic constant, and you will do your lab 2 later on, after you already finish and know how to do the basic assembly language. Okay, here you can see, first of all, we look on integer constant. So integer constant is a integer literal, which is optional leading by sign. Sometimes you have a sign. Of course, if you were not given with the sign, you always know it is a positive number. And one or more digit. And optional also to have a character or a radic indicating the number base. Let's say you have a number of plus 197 base 10. So this is our radic, this is our digits, and this is our sign. And radic may be okay, normally in our normal mathematical we put like that, right? 1 2 3 base 2, 1 2 base 10, and so on. So it is in numbering, but when you want to apply in the assembly language, that's why you need to learn on how to write up in integer constant. The format will be following this. Okay, you're going to write up, let's say, move EAX, the value of 101 B. So if it B, you know it is binary. Okay, if it does not write up like this, what is the value for this 101? Decimal. Okay, if there is no writing up anything, later on you will see, if there is no radix, it's going to assume to be decimal like this. Okay, so if there is no like unit at the back of the numbers of an integer, it's going to be decimal, our decimal number. So H will be hexadecimal, and in your data storage to be put into your stack, you need to always remember it always in the hexadecimal format. And octal, there is 2, Q and Z, O. Decimal D sometimes is also can be empty. Binary is B, R is, these two is rarely we going to see it. But this one, we always give to make you confused. Sometimes we give you Q, sometimes we give you B, because normally you know that it's always H, right? That's why we will play around with the value. Okay, so let's take a look at the example here. If it is just an integer number, it's going to be decimal if there is no radix that mentions. If D is decimal, this one is binary, this one is octal, this is also similar octal, this one hexadecimal, and okay, this one is also another important, okay, because later on you were given with like question which is not, or maybe the correct format for your integer constant to be written in your assembly language. So you were given with all the numbers. Suddenly, you were given with B10H, let's say. So is it correct or not the format for B10H for assembly language when you want to apply like move ataupun dot data B10H? Is it correct or not? Anyone?
Incorrect, doctor.
Yeah, incorrect, because it's need to
Leading zero.
leading zero if okay, if you're going to start with A, B, C, D, E, F. Because our hexadecimal nanti has F only, right? If G there is no, so it's always invalid. Okay, G and etc. So you need to remember back hexadecimal format number. You have from 0 until F, isn't it? So that is the format for hexadecimal. Now you already look into how to write the integer constant. This always apply on your dot data, because here you need to what we call clarify what data that we have. Maybe you have hijau. You want to assign like a group, or maybe you want to put some value to this. So you will put like 101 and then binary. And you can also put like 26 decimal, and sometimes you can have 420. And when you have this, you will need it. When you have this, you're going to store all the value in your stack later on. Okay, you're going to put everything here in your stack. Later on you will learn, okay, but now I just give you the overview. That's why it's important for you to look into the radix here. If you don't, you just tag this, like maybe you tag 101. Okay, you put 01, 01, and then wait, maybe at here we start at this address, we go down. Okay, maybe we put first, we pick later you will learn also in the Little Indian order. I think you need to pick the back first and then in front. 01, and then another one is 1, but there is nothing in front, you need to put 0. Every tab column like this, you need to have one 2-bit value. Okay, but this one, oh, I forgot. If you put directly like this, okay, if you put like this directly, you will get wrong, because this is binary value. To store in your stack, you need to change this 101 to hexadecimal first. Then after you convert, maybe you will get like 1023. Let's say, okay, you convert. So you will pick 23 here, then you pick 10. In front of this also you need to have the declaration whether it is byte. This will be a size. You will declare how many size that each of these will be represent. After that, you follow on this and this to store in your stack. So that is the purpose why you need to know how to write this and to divide. If it gives you B, you need to remember you need to convert to hexadecimal. If you were given with D, you need to convert to decimal, hexadecimal. Similar also the rest. Okay, so you need to know how to convert. Next, when you have the real number constant. When you have the real number constant, you will play around with a sign. And also there is another one is exponent. How you going to write in the assembly language. So this is example how you can write. You can put like 2 point something. This one is valid real number constant. And this is the format. Okay. In front of this, sometimes there is no sign because normally if it is no sign, we assume it's positive. So you have integer here. Then you have the radix. The rest is not because sometimes if 0, we just assume it's 0. So this is also correct because it's follow the format. After that, you can also have the character and string constant. When you want to define in your C programming also, you need to differentiate between character and normal integer. So character will be a character constant is a single character, which is A, B, C, only single, okay, until Z. And it will be putting single or double quotes like this. You cannot just simply put A without putting a single or double quote. Then your machine will not recognize what is basically A for. Okay, so if you want to write a const character, you need to put the single or double quote. Compared to the number just now, digit, no need for you to put like 101 binary. No need for you to put single or double quote. Okay, it's only apply for character and also string. Character only single, but for string you can have a lot, which is like a sentences also can, but it's more than one. If you have A, B, also it is a string. Okay, it's a sequence of character, including space. When you have A and then you have space here, you put a single or double quote, it also a string. And you can see here, this is example, might be there is a space here. So it is a string, constant. Enclosed with similar also single or double quote. When you have the number here, you can see digit here can be also a digit, your integer. But when you apply this, it is not integer anymore, but it already become a string constant. Okay, you need to differentiate. When you apply this, it is not integer anymore, it is a string constant. So it is a ASCII character 1 byte, and each character occupy a single byte. Okay, this is embedded code. Embedded coded permitted when used to manage on a following example. This one you can also having double quote in a single quote. When you have double quote, you can also have a single quote inside. So which one you're going to print out later on? So you're going to print this. Here you're going to print this. Similar also, you're going to print this one. That's why you need to know where you're going to apply. You cannot like, I think maybe you can put like this and you print only this. So how to apply it, you need to know, okay? Later on, okay, here will be reserved word. Okay, there is also like limitation for you when you want to apply into your programming. The things that you cannot use to declare your data. Okay, reserved word cannot be used as a identifier. When you want to declare, you need to use the identifier to identify and declare your data, right? But you cannot use a reserved word. Before you can go here, you need to know on identifier. Okay, what is identifier? Later on, we will go back to our reserved word. So identifier is identify a programmer chosen name. You are the one who choose the name. It might be identify a variable, constant, procedure, or a code label. So normally, the one that you put like dot data here, when you want to name whatever group, everything is you decide. So you can just put whatever saya, kami, whatever that you choose, or might be it is not even a correct grammar, or might be we just say. Because you want to put saya but you accidentally put say. Still, it is okay, but you need to point up similar lah. Say, and you put at the back on your dot code here also say. As long as it is identifier, it can be any name. But still, there is also limitation, which is it must contain 1 until 247 character. It must contain the characteristic, which is you have number. You can also put like SAYA1, SAYA2 to identify and differentiate between each other. As long as it have a digit, it can also have a character. It not case sensitive. You can put SAYA. You can have the capital letter and small letter also. It's not case sensitive. And subsequent character also in between, you can have a number. That's it. So you can have also a digit in between. And this is the thing, identifier cannot be same as assembly reserved word. Okay, you need to know first before you can move to the programming. So what is our reserved word? We go back to this part. Reserved word is reserved word as instruction mnemonic, directive, type attribute, operator, and predefined symbol. What is the instruction mnemonic? Later on you will find here. Where is it? Instruction. Here under instruction. This is instruction mnemonic, which is you're going to learn on instruction. This is one of example of reserved word. What is it? Like operation. When you need to move, you give instruction to your machine, to your computer to do the operation. So you give instruction, move. You also can give instruction to do operation of addition and multiplication, subtraction, and etc. Okay, this is instruction mnemonic. After this, you all will look into instruction. Directive. This is directive, which is normally will directive with library. So it's going to have the include. Type of attribute. Normally you're going to have the byte, word, double word, F word, bit. So there is a lot. Okay. What else? Just now between byte and word. There is one name here. Anyone remember?
What is it, Doctor?
Again?
What is it?
You have bit, you have byte, and then there is something here.
Nibble. It's nibble.
What symbol?
Nibble.
Nibble, yes. You have nibble. So all of these is type of attribute. You cannot use to be as an identifier. Okay, thank you. So operator also cannot be as a identifier, positive, negative. And lastly, predefined symbol, which is like this. We can have something here, but this is cannot be used for the identifier. Okay, go directly. You can see this is under identifier. For identifier, you can use all the symbol, all the digits, and also the character. But if you use the symbol of this, predefined symbol like this, it used to extensively by assembler as prefix predefined symbol. So avoid using as identifier. Okay, you need to avoid to use that. Although it mentioned like this, first character must be a letter. You cannot use a predefined symbol. So what is the example of identifier? So here is the example. You can always use a symbol, numbers. There is no number in front here. A character, whether it is capital letter or small letter, it's always okay. In between, when you want to have a digit also can. Next, we move into directive. On the directive, there is several directive in your one programming. One single program, sorry, not programming. One single program, you're going to have several directive. Directive is a command embedded in the source code that recognized and aid upon by the assembler. Now you're going to have .data, .code, what else? It is not execute at runtime, can define variable macros on procedure, not case sensitive. You can use the small letter like this, capital letter also can, and a combination also can for the directive. And different assembler have different directive. So example shows between directive and instruction. Okay. Here you can see directive at this side. Mana dia? Okay. This is one single line for your programming, for your program. You have my var d words 26. This one is what? Decimal. And this is what? This is command using assembly language. Yesterday, your friend mentions that we have a lot of error for our Visual Studio when we run because we are using a command following assembly language. I don't know whether you are having a similar problem with us or not. It seems like our Visual Studio are detecting C++ rather than our assembly language. Okay, for here, Later on, you will see this is one of example how you're going to write your comment. There is two way for you to write a comment. So this is one of the example. Okay, this one is a comment. Why you need a comment? Because this one shows you it's not going to read as a program, but it will show as a comment, means that whatever for here, this is mentions, the word is directive. And for this MOV, this one we know it is instruction for you to instruct the machines to do a MOV, move instruction. So execute at runtime, copying the content of my var here. We're going to copy this my var to be in EAX. So what you need to do first, you need to convert 26 decimal to hexadecimal, and in your EAX will be having the value of 26 decimal, but inside the stack it's going to be hexadecimal, right? On the instruction is an executable statement when a program is assembled. So instruction are translated by assembler into machine language, but which is loaded and executed by your CPU. You can read this. So there are four basic part in one instruction. So you will given one instruction like this. Okay, you are given with one instruction. So what is needed in one single instruction? This, so you need to have label, but it is optional. You need to have instruction numeric, it is require a must. Okay, so this is the one. Next, you're going to have operand. So it's usually require. So I think this one is the operand or this one. So you need to put the value inside. And lastly, a comment in one single line. You can see you also can have a comment, but it is also optional. If you don't put this one, also can. Okay, so here you need to also look into how many operand that you can have. You can have the minimum is 0 operand, maximum is 3, if I'm not mistaken. After this, we look into all of this one by one. Let's take a look first on label. This here, which is optional. You can have, maybe you can also didn't have the optional. It's depend on the programmer. So what is label? A label is identifier that act as a place marker. So sometimes you need it, sometimes you no need to have a label. Follow identifier rules, which is you're going to have two: data label and code label. For data label, identifies the location of variables, and for code labels, it's use a target to do looping. So what is the example of data label? So this one define a variable named count. So this is the data label. Count, so you pick from your dot data, there is a count. Or might be here, this one you need to count this as 100 decimal for the D words. This is the variables that you will given by a programmer, like this identifier. It's quite similar to your identifier, but it is a data label. That's why it's follow the identifier rules. For the code level, it's going to use like this, which is you can have this, like maybe you can put loop, maybe you put sire. Later on, you will pick this one, jump to sire. Let's say you put. So this will be go here. Why I can put saya also? Because it's follow the identifier rules. If you still remember, identifier rules is programmer choose the name. So you can normally use any name to put here at the code level. But there is an instruction there, jump instruction will transfer to this target. But this is the one that your code level. The data level is here. Okay, second, you're going to have instruction numerics. Where is your instruction numeric? Your instruction numeric is this one. If you look at this single line, as just now we look here, this is your instruction numeric. This is your operand. And here is your command. Instruction numeric is a short word. Short word. That's why when you have move instruction, you want to give a move, but you just pick move. When you want to have the additions, you just use ADD. So this is all the listed normal instruction numeric that we will use. Move, add, sub, mul, jump, and call. Normally, jump and call, we are going to refer to the code level. Next, we have operand. Where is operand? Normally, operand is between 0. Okay, this is the things I mentioned. There will be a limitation for operand. You can have the minimum of 0, just now I mentioned, and the maximum 3 operand in one single instruction. Okay, in one single line, you need to have maximum 3 operand only and minimum 0. Then you're going to see what is the difference if you use 0 operand, single operand, 2 operand, and 3 operand. You're going to have the difference in sequence. How long your programming will be taken. And this is example of your operand. One of that is a constant. And then you can also constant expression, register, and memory. That's why I mentioned in this single line, you have 2 operand here. Your register is kind of operand and constant here. Sorry, this one is not constant. This one is what? Memory. This one is memory. So you have a command later on we look into. So you have now things of operand 2. We have this one is what? Instruction numeric. And this one is command. Let's take a look into here. We have instruction numeric for move. We have operand, 2 operand at this example. We have EAX for register, and we have the count. Just now. Or data, I forgot. So this is operands and command. So this one is normally require and similar also operand. But sometimes you don't have any operand because it is a 0 operand, right? So usually require, but sometimes it can be 0. Okay, now here is an example. Here when you have no operand at all. This is single line, single instruction. STD, which is set carry flag. Increase EAX. You have only one operand. This one is your instruction numeric. This one is instruction numeric. This is operand. One operand. Okay. This one is command. What is basically this line doing? And here, how many operand you have? You have 2 operand. And this is your instruction numeric. And last time I give you the overview. Normally we will like dari dari Johor, from to Selangor. Normally we like say, okay, I'm going to go from Johor to Selangor. If we want to give instruction, daripada Johor to Selangor. But in our programming, we will put to Selangor from Johor. We are going to go to Selangor from Johor. So here is your destination, but this is where are you from? From BEEBX to count. At this instruction, this is always been applied, okay? This will be always applied. You need to have destination here, and this will be your source. It fixed, okay? That's why for this instruction, okay, let's say you have like move, move EAX 5 hexadecimal. So you're going to put in your stack 5 for your EAX value. You put here. Later you look into your lab 1 back and see the value. Means that from here, from source, you put here. When you have addition, add EBX with the value of 5, let's say. So this will be add with the value inside. And you store at this back. Okay. Next, you have comment. You can try to read this, why you need a comment, okay? Why you need to have a comment for note and etc. This one I already informed just now. But this is the important, which is you have 2 type of comment, which is single line comment and multi line or a block. This one you see in your lab 1. You see in front there is a comment. So all after this, it is not related to any programming. It's just for a programmer. For a programmer or technical to understood. Mana okay. For a programmer to design, a person to reading the source code. And how? Single line is begin with semicolon and multi-block is going to start with comment. And you have the symbol like this, and also will be end together. If there is no here, it is not going to be complete comment until it form like this. Might be in yours, in your code, it will be having this, then it will read all together as a comment. Okay, any question? After this, we will look on register and also the size of the register. Jam saya habis bateri. So any question? If there is no question, let's remove first for our register. Okay, register is it is not started here, but it is like a temporary memory for you to put. Normally we say like we're going to put in our stack. So where is the stack we're going to put in our register if we define in our instruction or program that we're going to apply our register to be the storage. Okay, so there is a few register name that you're going to find out. It is not stated in your COA subject. You can try to Google. Normally you will find A, B, C. What else? There is a several. So this is always been used in our subject. A will be accumulator. B will be base. C will be count. Forgot this one. You need to check back. Later I give you the notes. Last time I have it. Let me try to find out and I share. Okay. Where is our group? Okay, you can also try to find extra information about this register. I give you the picture in the WhatsApp group. Okay, this is the one you're going to see. A for accumulator, B what is going to use, B is for best, or C is not. Just now I call what? Count. Counter, it is count. D for your data. This one is we rarely use ESI, EDI, BP, ESP. We rarely use, okay? We will always use like from D and above. Okay, let's go back to our slide here. Okay, in terms of the name just now, don't confuse, okay? You're going to find R and bumper into EAX. You're going to also bump it into AX. Although it is a similar type of register, which is accumulator, but the size is different. Okay, the size is different. You're going to also have EBX, ECX, EDX. Similar also, you're going to also have BX, CX, DX. But the size for this, in your notes, although it's just look EAX, but it is applied into all, which is the size is 32 bits. Okay, for AX, BX, CX, DX, the size is 16 bits. And you have another one more, which is AH, AL. You have BH, BL. Similar, okay? The one, the only different at the beginning here, okay? AH is accumulator high. High, okay? This one is low. LOW. Accumulator high, accumulator low. Base high, base low. And the size for this board is 8 bits. 8 bits. Although this one like BH, but we rarely find this one, okay? We always like use AH, AL. There is a size of 8 bit. This is 8 bit and another one is 8 bit. Okay, so this is not in your notes, in your slide. There is no sharing in detail. You don't were given with the name, what is A, what is B, what is C, but instead you just given directly the short form of the register. Okay, in size you need to remember why it's important, because later on you will play around with the addresses with the stack. You were given with the address. Let's say you start in the question, you're going to start with like address start with 4000. So at the beginning it will be 4000 here, okay? Here will be 4000. And then you're going to have 4001. This one is not given. It got just normally given the initial value of the address. So you will follow 002, 4003, 4004, 4. So each of these will require 2 bits. That's why hexadecimal value you were given like 3, 2, 4. Okay, dot data, this one is might be what we call whatever storage maybe. It is our name that we define, and the size is byte. So if size is byte, you need to know byte is require you 1, 2 address. This is 1 byte. So you will take this 2, 4 and this 3. You need to put 0. This is byte. If here, okay, similar store, but I change the size. I put words. Word, the similar amount 3, 2, 4 each. How you're going to apply in your storage, in your stack? Because this one is you need to put carefully, because all of this require you marks in your test, okay? So here you're going to put 24 and then 03. The size of word is 2 byte. 2 kali 2 byte. One word is this one. One word is 2 byte. You can see this is 1 byte. Sorry, this is word, which is 16 bit. 1 byte is 8 bits. 8 bits. 1 byte, 1 byte. Okay, and then this one you're going to have nothing in front. That's why you need to put 0, 0, 0, 0. Then you're going to continue. Later on you have data, maybe that, okay, byte 1, 2 H. So you will continue, you put 1, 2 here, and then there is a 0, 0. So this is how you're going to apply later on, but we will later on see it. Only you need to know in size, byte, word, the word, and when you apply in terms of EAX, EBX, the value of 1, 2, 3, hexadecimal, you need to know, okay, EAX is 32 byte, which is double word. So you need to put 4 box, because it is double word, let's say. So you need to put 23, 01, 00, 00 for your EAX. Okay, deeper we're going to learn later, but I just want to make sure all of you will remember that AH is 8 bit, which is 1 byte. And then you have AL, another AL, which is 8 bits, which is 1 byte. And then combinations of 1 byte, which is 2 bytes, will be having a words. And after that, you're going to have also the word. In between, as mentioned as your friend, we have a nibbles. A nibble will be 1 byte. This is nibble, right? So you need to know about nibbles also. And here is the size. You can see you have a B, C, D, and etc. 32 bit, 16 bit, 8 bit, high and low. Okay, let's take a look into what you see in your program template at your lab 1. Okay, you can read all of this. Okay, inside our template.asm, we have several things. Just now you learned already, right? Okay, now you know this is all command. Then you have what here, data, and then we have a manprog, exist. So this is the basic architecture before you can start doing a programming for assembly language. If you didn't follow the architecture, then normally you can get error. You cannot have one program. So you needed to do write the following program, copy this, and then put in your Visual Studio. Try to run because this one is nothing here. So write the following program in text or notepad, save as template.ssm. But basically we done this, we just directly give you the template already. And we're going to do an example of addition and subtraction into our coding. So over here, similar to your, I think lab 1, question part A. So you have the dot code, which is first you give instruction for move. You're going to move, this is what? Source. This is what? Destination. You're going to move this value to EAX. If your value here is B, please make sure you check carefully. You cannot directly take the value to put in your stack. You need to make sure this is hexadecimal. Okay, then here you're going to see, okay, in your register EAX now, after you finish this line, you're going to have 10000H value. And you move step over to here. You're going to do the addition. Add this value. This is what? Source. Add this value with your EAX. Then you're going to also having the destination to your EAX also. So you're going to add, you're going to have 50,000 and you store back to your EAX. After that, you're going to do the sub. You have just now 50,000 hexadecimal. This is your source. You're going to deduct sub with 20k hexadecimal. And you will get the value of hexadecimal 30,000. And the answer you're going to store back. This is what? Destination. That's why at the end, when you run this program, you're going to have the value of EAX equal to 30,000 hexadecimal. Okay, any problem to understand? You can see here, move, which is you're going to copy the value to your EAX. You're going to add 40 hexadecimal to your register EAX. And then you're going to sub this one from your EAX value and store it back. Okay, there is also another one more thing. Try, okay, please try remove this in your lab. This one is to display the register. If you don't do this, you cannot see the output of your register. You can run, but there will be no display for your output. That is the function of dumb register. If you remove, there is no error for your program, but you cannot see. Okay, you cannot see the output. Okay, now this one is the output that you're going to see if after you generate the call dump. Okay, if not, you cannot see the output. You cannot print the output because you did not call the dump register. What else? This one, right, and save. Okay, this one is similar. Subtract. Okay, let's move. What is time now? Okay, maybe we can have a break 5 minutes. After that, we're going to continue with our size of our addressing and how you're going to store. your value. This is the little Indian order. Just now I mentioned to you how you're going to store correctly. If you have the value 1, 2, 3, 4, 1, 2, 3, 4, saya, words, how you're going to pick and store correctly in your stack. You cannot just stack, okay, 1, 2 here at 4000 at the beginning of your address, and then after that you put here 34, and then you just pick here. You need to follow the little Indian order. How? Okay, later on after back we will learn on this. Okay, so let's take a 5-minute break and then we continue. Okay, shall we continue? The rest. Okay, if you already stand by, please enable your webcam so I know that you already in front of your computer. Okay, now let's take a move to our defining data. There is several, not several, there are too many, I guess. But you need to see now you have a lot of other different names like byte, words, D word, SD word, S word, T byte, Q, and etc. So you need to know about their size also. So let's move one by one first. Intrinsic data type. So each intrinsic data type describe blah blah blah. This one you can look into. But assembler is not case sensitive. That's why you can name it with a capital letter. You can also having all small letter, and you can have in between small and also capital letter. Okay. And normally the size will be like this: 8, 16, 32, 48, 64, and 80 in increase. Normally, the maximum we will play around with our stack, and also our size will be maximum, I guess, 32, which is the word. Rarely we find more than that, although you learn on sizing or numbering last time, 64, which is double precision number. But in terms of our assembly language, we just always like use 32 bits, the maximum. This depend, we don't know after this. Okay, this is the size. Byte is 8 bit. S means sign. Okay, S means sign. It is a 8 bit, but it is a sign. And you have word is 16 bits. Means that one word you have 2 byte equal to 4. 1 byte is 8 bits. So if 2, you have 16 bits. Next, you have sign words, which is also similar like this, 16 bits. And double. Double mean you're going to have D words 2 times, going to have 4 bytes, which is altogether times 4, going to have 32. Times 4, 32. And F words, Q words, T words, we rarely use this, but might be it can come out with the question, multiple choice question, in terms of the size, whether it is correct or not. Which one is correct, which one is wrong in terms of the size. But normally in our assembly language, we didn't use this. Might be it's too big. Okay. Now, in terms of the data definition statement, you're going to have on the data definition the name, the directive initializer, and you're going to have at least one initializer. Example, count the words number. Okay, this is the things that you can define. Might be you want to group a name with yellow, green, red. This one is you can define any name here. Okay, and this you need to follow in terms of the size. You need to follow on the type of size here. D words, by words. You can see that's why normally in maximum we use D word. We rarely use F word, Q word in our assembly language because of the size. It's very occupy many size for the addresses letter, so you hard for you to write in the answer in our e-learning. But you need to understand in terms of the size. Okay, now when you are having here, you can see this is not hexadecimal. You need to see this is what? Decimal. So that's why you cannot directly tag this and put into your stack under a count. Under count, you cannot put into the memory of count here, starting directly pick 4, 5, 2, 3, 0, 1. Cannot, because this one is decimal. You need to change it to hexadecimal first, similar to this. This one, because of M, you can directly put, but I think you need to check in terms of the value. M normally, can we convert it hexadecimal to this character to hexadecimal? Later I will check, okay? But this is example only. Normally we will give you in the value. Okay. Then we need to learn how to pick all the value. Just now you can see count, the words, this value. How you're going to tag this to be in the stack. Let's say we have double word, but normally we didn't put like this, okay? We will put like D word or D word or whatever capital letter or small letter, but we're not using double word. D word, in front we declare with something, especially for this tag, for whom, or maybe this is for your register, or might be this one for like a green. So this is the value for your green memory. So you will have initially in your question, we will give you the value of the address, or we call as the offset. Might be in the question we not given with the initial value, we just assume it start with 000, okay? So every box here, every single address, it occupy 8 bits, which is 1 byte. Okay, 8 bits or 1 byte. So here we have double word. If double word, 1 by 1, we have 1 byte, 1 word equal to 2 byte. If we have 2 words, which is double word, we're going to have 4 bytes. Okay? So 4 bytes mean 4 box or addresses or offset number. Okay, I always put a box. 1 box equal to 1 byte. Here we have D words like this value. This is direct hexadecimal, that's why we can directly pick. But in terms of Little Indian order, we didn't pick in front number, but we will pick at the back. We will pick this first. Okay? This occupy you 1 byte. 1 byte, okay? Normally this one will be 4 bit, 4 bit. If you remember in terms of binary, 8 bit, 8 will be like 1000. This one is 4 bit. Okay, this is the maximum that you can put here. The maximum will be 1111. What is this? This is F. That's why it is only 4 bits. Okay, 1111 is F. In hexadecimal, it is 4 bit. 4 bit, 4 bit. Okay, you have byte. 1 byte, 1 byte, 1 byte, 1 byte. Apa pensel ni? 1 byte, 1 byte, 1 byte, 1 byte. And this is 1 bit. Byte. 2, 2, 2, 2. Sorry, 4 bit. 4 bit. 4 bit. So you need to know how to check the size. Why it is 4 bit? I already mentioned this one. The maximum for hexa number is what? Until F. Isn't it? F equal to 1, 1, 1, 1. The value is 15. Okay, 15 will be 1, 1, 1, 1. It is F. It is only 4 bit. 4 bit, 4 bit, 1 byte. Okay, now we're going to put into our start here. We will start Little Indian order. We pick the end of the number and we will put this to the first address, to the first offset. 0, 0, 0, 1 byte will be 7, 8 hexadecimal. We pick another one, which is 5, 6 hexadecimal. We pick to the next one. We pick this one, we will put to the next offset. We will pick this one and we'll put to the next offset. Okay, any question? If you were given with like D words, 1, 2, 3, 4, 5 hexadecimal, what is the value inside? You're going to pick this 4, 5, this one, 2, 3, this one, 1, 0. Okay, 1, 0. And the in front one is 0, 0. If you didn't put 0, 0, later on when you want to continue, because there is like after this, you're going to have byte 2, 3, 4, 5, let's say. So when you put your addresses, when you tag this, if you don't put 0, 0, of course, you're going to put here at 0, 0, 0, 3, right? So you're going to get wrong. Please make sure carefully you know the size. If D word, you have 4 offset, 4 box. You need to occupy all. Although you don't have value in front, you need to put 0, 0. Okay? Example here. This one, you have duplicate. You're going to do 2 times. Let's say we have D words. Okay, D words, how much? 4 box. Let me start with 0, 0. Okay, I don't have ruler. Sorry, always been ugly. 1, 2, 3, 4. Okay, let me do it scientific. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Kalau double word 4 times 12. 12, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Dah terlebih 1. It's okay? We start with 0, 0, 0, 0. Normally in question, again I mentioned, normally it's going to give you starting value, okay? Initially, the offset will be start at like 401. Then you need to write the address 401. But let we start with 0, 0, 0. So following the Little Indian rules, this one, we're going to pick this first. Then we will do here. Although later on there, we're going to pick the at the back, right? But please make sure, although it is at the back, if you have 2, later on you can have 3, 4, and etc. in terms of the number. But you need to do this first and then continue this. Okay? Only you need to pick this one first. Okay, for this part, you need to change this to hexadecimal first, but you do it by yourself. I just show you. Let's say we assume it's to be hexadecimal, okay? I will pick this one to be here, 2H, this one, 06, this one, 47, and another one, 03. I finish this first double word. And there is another double word for this size. This size is double words, mean 4 box. 4 size, but there are mentioned here 2 duplicates, mean 2 kali, 2 times. You will do it 2 times. Let's see what will happen. Mana pemadam ni? Okay, first we're going to do it at the end. Okay, starting from here, it is hexadecimal, we will put this one, 0E, and then CD, and then AB, and another one, 02. And you need to duplicate, means that you do another one more time, 0E, CD, AB, 02. Until what? 12. 4 word, a double word, another 4 here, double word, and here is double word. That is correct. This is how you're going to put in. Later on, you're going to play around. You not only give one line, okay? You're going to have my data 0, my data 1, my data 3. So you have byte. We will play around with the value 101, binary. And then we give you like this, just to make sure you focus. If there is no symbol here, it is the decimal. You need to convert to hexadecimal. So please make sure you check carefully. Okay, this is 101 and then 1, 2, 3 hexa, let's say. So you need to follow the sequence. You put this first, 000 byte. We do this. Alamak, this one is binary. I pick hexadecimal first, okay? 01. And then we have another one is 01. This one is byte. Sorry, this one is byte. That's why I can only have this one. Okay, this one is 01. And then we have another one, 12. 1, 2. Byte, byte. Finish after this. Okay, I done with these sentences. 0001. And then move to here. 0002. I need to do this one. And then after I finish just now until 00014, I will start 0015 with my data.3. So that's why it's important, because after you fill in all the stack inside the value, the question will be saying at 0015, what is the value? So if you wrongly fill in, you will get wrong. Okay? So it's very important for you to know the step. Here also similar, but it is word. You can see if word is 2 box only, 2 box, but it is duplicate. So here you will do what? For F00. Another one more time for F00, because it's duplicate 2 times. After that, you have this one. You put like this, but you have another one. But this one, you need to make sure, check hexadecimal is what. I think there is a thing here. Later on, we look into, after this, there is a requirement for you to change the character, the symbol from this to be put inside your stack in terms of hexadecimal value. And then after that, you have 200 B 000, and then 25. This one is decimal. You need to convert also 00 and 0005. This one is T005. So maybe you can try to do all the exercise. If you have any question, we will discuss together. And if you did not sure, you can try to assign it to be EAX. Do it one by one. EAX words. Let's say you put you put EAX the value of like this, and you have words. You duplicate this one, you put in your assembly language and try to run at your Visual Studio. See what is the value of your EAX? Normally, it's going to convert to hexadecimal. Okay, now let's see who can answer this exercise 3.3. Please make sure you open now for your exercise 3.3. I'm going to call someone to answer what is the value of EH, what is the value for Muhammad Al-Fikri. Amir Muhammad Al-Fikri. Amir Muhammad Al-Fikri. Are you here or not? I panggil banyak kali, kalau tak ada, I buang Yeah, I already removed. Okay, let's try perempuan yang pula asas lelaki. Nur Fazlin. Exercise 3.3. Okay. What is the answer? Okay, for this one, for this question, we have three things. Okay, what is the value of AH?
I'm not sure, Doctor.
Fikri, tolong kawan you ni. Fikri Akmal. What is the value of AH?
Yes, Doctor. Wait, let me see. I think I didn't get, maybe 0.
0? Okay, I put just 0. Haikal, what is the value?
8899.
8899? I pernah ajar banyak example tadi ni. Kita pilih Zafran, what is AX?
Yes. I'm not really sure about the answer, Doctor.
Cepat pergi direct copy this, run dekat Visual Studio.
Wait,
Uh,
wait.
okay,
Doctor,
yes?
can I answer again for AH?
AH, okay, what?
I missed. Okay. Wait, BX. For AH is maybe 34.
34. Hexadecimal.
34.
Okay.
Thanks.
Thank you. AX, Weijian. I salah sebut nama you ke? Weijian,
0.
0. Okay. Thank you. But, okay. This one is 0. Okay lah. Hexadecimal. Kalau dalam a stack, we're going to do 0, 0. Okay. BX. BX. Perempuan lagi. Dah habis dah kat sini. Tak ada. Okay, Iqmal Aizat. BX.
6678.
Okay,
I think.
first you kena do apa ni, several carefully to look into the address. Okay, you said 66 ah?
I think 6678. I think lah.
6678.
So,
What? 66?
sebab dia 78 sebab dia based on val 1 plus 1, right? I think.
Okay. Let's see the answer. Oh, macam I pandai. You can try to copy and try to run at the Visual Studio. Okay. Meanwhile, you can see here. First of all, when you have the program, you're going to store dot data first in your stack. Okay, you're going to store first because you're going already try to assign. Okay, first of all, you're going to have CTH. CTH, the value is byte. So your storage, your storage will be start might be 0000. Okay, from here we're going to have byte first, CTH 34, and then CT hash 2 FF, and then you have var1. You follow the address, of course, after this one by one. VAL words, we're going to have 7766. Okay, and val2 we have 9988. So finish on our data. Now we go for our code one by one. First of all, we will move this value from our source to AX. Now our AX equal to 0. Hexadecimal, and if we put into stat, it is also 00 hexadecimal. This one is decimal. When we convert also we will get 0 for hexadecimal, right? After that, for this line, MOV, move this source to your AH register. You need to know register AH is 8 bit. 8 bit and 8 bit is 1 byte, isn't it? So 1 byte CTH. This is our CTH. It is 1 byte. Okay, this similar. Then this is the value of AH34. After that, what we're going to do? MOV 0 to our BX. Now BX equal to 0. And after that, we have this value to be put and fit into our BX. What is the meaning by this? This means our value of VAL now, you can see VAL is word. We have 1, 2. This one is start might be like val1. Where we have +1 means that here we start, we will add 1 offset or 1 address. We move to here. If it is +2, it's going to 1, 2. This is the value that we will take. Okay, so it's going to plus not the value inside that we plus, but the value in the value of addresses, our offset. When we start VAL at 0003, we're going to add our address to be with 1. So it will be 0004. At what? 004, what is the value? It is 66. So we will put it into BX. Now our BX will be 66 hexadecimal. Okay, so here 34 hexadecimal 0, and here is 66 hexadecimal. Okay, so any question? Did you clear about this? Because this one is not asking you to add 1 with your value in the memory, but your value of your offset or address will be increased 1. So now you have like val now, Little Indian order, this will be start first. If you +1, you're going to jump here. So this is the value. And you need to check that BX is 16 bit BX is how many? 16 bit 16 bit. Oh, okay, 16 bit. Supposedly your answer will be 0066, or after this you're going to have 99, so you have BX equal to 9966. Sorry, just now I just looked into the value of +1. I just point to the exact value. But you need to see the type. BX is 8-bit or 16-bit? Alah, tolonglah.
It doesn't mention, doctor.
BX mentions already here. Just now I already teach all of you. Where is the register? Here. Mana tadi ni? This one.
Oh, okay.
Just now I already shows you, right? So if it is 16, means that it is 2 byte, right? This one is 1 byte. So you need to occupy 2 box. Our question. Okay, so you need to occupy 2 box, means that you have 9966, because after, okay, start VAL at 0003. If you want to plus 1, you're going to have what? 0004 for this. You point here, which is 66. After that, you have VAL2 0005, which is 9988. So because of this value is byte, okay, byte which is 16-bit, you're going to have 66 baru 8 bit. It's just 8 bit. So you need to add another. You tak boleh add sebelum It's going to be after. So it will be 9966 for this BX. Okay, ada lagi tak soalan example? Okay, let's take a look another example in terms of byte and sign byte. Okay, if you have value 1 byte, so byte is only 1. Just now I mentioned, okay, let's take a look how these things can be stored in your storage. This is character. Another one is symbol. So symbol is an identifier byte. So please make sure you still remember this, but you need to store in your storage. Following this example, how we going to store? Okay, this is the example, okay? One by one, we will start with 000. In your question, in your test, in your final exam, they will be given the initial offset. Normally, it's not start with 0, okay? So, value 1. But mean 1 box only. Going to put your character inside. And then, you have here 0. Means this is byte, this is decimal. You will put 0 in front here, but please make sure you use 00, okay? Because this is a 4-bit, 4-bit. And this is not character. Unless it's a character, you can put like this. But if it is a value, please make sure you put 00. If not, you're going to mistake later on. You, by mistake, you assume it's only 1. Later on, you combine with others. Alhamdulillah. Wait, I need to pick a call. Okay. So let me continue. Sorry for the interruption. So you can see here, this one. Mana pen saya? Dah lukis kan? Okay. This one is decimal. See? Decimal. You need to change to hexadecimal to store into your stack. See, right? You cannot just directly copy like this 55, put here, then 02. Of course, this one is also byte, it's only occupy one box only. Okay, so please make sure if it is decimal, you need to put it in hexadecimal. This one is also decimal. You need to put it in hexadecimal. And this is also similar. But for this is the value of unidentified byte. So normally for here, where is the statement? Normally we just let it like this. But it's okay for you to put like this inside. Normally this we know as unidentifier byte. Please make sure you see this, okay? Similar also this one. If it word, okay? If it is word, you're going to put like this here and you're going to have 00 after this. Please make sure you know the size. Similar also here. If you have word like this, you're going to have two boxes for identifier. This one you put here first and then you put 00. In terms of the size is very important because the question will be asking, okay, at the 0007, what is the answer? So for here, if you mistaking putting the value correctly, then your answer is wrong. Okay, let's take a look also in terms of when you have multiple. Just now only one value in one line. But similar also we already done for this exercise. You can see for this exercise also we already done, right? So similar also for this example. For this example, first you have list 1. This is byte. Byte is one box, one offset, one address. So you will pick, I already mentioned, although Little Indian order, it require you to pick the at the back value, isn't it, for hexadecimal? But what you need to do is, for if you have like comma like this, you need to pick this first. Okay, this will be value for first, and this will be second. This one is decimal, you convert to hexadecimal, okay? And this is the thing. This one is just for you to teach how to put inside, but please make sure you convert this to hexadecimal. And here, this one, you're going to put this Y only like this because this is byte, one box. For this, you're going to put 41 hexadecimal, and this to be here. And you can see in terms of data labeling, just now you see at this var1 plus 1. Similar also in this example, when you have list 1 plus 1, if the question said plus 1, which one is your answer? You're going to get this. See? List 1 plus 1, this is your answer. List 1 plus 2, this is your answer. List 1 plus 3, this is your answer. So similar to the rest. Okay, plus 1 not means the value inside you're going to plus with 1. Plus 3 not because of the value inside you're going to plus with 3, but it's going to plus the offset, the size of the address. Another one box, okay?
Doctor,
Yes.
why didn't we convert the binary on 0003?
Okay, just now I already mentioned this one is just example. Please make sure in your exam, in your test, you put inside the hexadecimal value, okay?
All right.
Okay, this one is decimal, this one is binary. That's why it put here the symbol. But this one, normally we will play around with hexadecimal. Similar also in your Visual Studio, your addresses, the value for your EAX, EBS, normally it is all hexadecimal.
So always convert to hexa.
Yes. All
Alright.
need to convert to hexa. That's why in your test, we always give you different value at the back here just to make you do several steps before you put the value inside. Okay. Defining string. This one string related to your character. How you going to print screen later on in terms of example like this. Greeting 1, size is byte. This will be occupy only one box on the size. After that, you have this. Let's see. We rarely put the value for this to inside your stack, but you need to know this is the things that inside your first character of your offset. 001, there will be good afternoon, which is the size is 1 byte only for your string here. There is another one, 0001 will be your 00 here. The rest is also similar, but this is in terms of string. How you going to use your character to play around with your assembly language later on. But you need to have the size. This one is also similar. In terms of DUP, duplicate, we already look into the example. You need to duplicate. If duplicate this with 20 times, so you need to have 20 bytes, because 20 times, okay? This one 3 times, only 3 times you're going to duplicate with the value of your byte here. And COE 3 times, 1 2 3, and you have what else, byte 10, which is byte. This one is normal just now. So in terms of DUP operation, you need to know what is the meaning. You need to duplicate. Words and sign word. Word is this one is largest numbers that you assign, that you can put into the word. Similar also. I think it's not too hard because we done already together. Okay, let's see in terms of how we're going to put into. This table is similar with the one that I draw just now, which is 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 2. Here is also similar, but it will be like this. This will be 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 2, 0, 0, 0, 3, 0, 0, 0, 4, 0, 0, 0, 5, 6, 7. Okay, because in your e-learning later on, sometimes it depends on the lecturer. Sometimes they like to put like this, but sometimes it's too long because there are too long addresses. So that's why sometimes we draw in terms of like this. So we will given only the value of the beginning. Let's say we put 4010 as the beginning. So you need to know after that will be 4010, 40, 12, 40, 13, and etc. Okay. So let's see the example here. We have VAL D word. D word how many? 4 box, 4 address, 4 offset. We're going to pick which one first? This one. Okay. This we will put at the beginning. We put here. And then we pick another one. This one. Pick this one to here and another one to be here. So this one is easier because we done several exercise together. And for val 2 here, Last example only. Later on we stop our class. Okay, we already exit 4 p.m. Sign double word. See, this value is decimal. You need to change it into hexadecimal. Okay, you change to hexadecimal. What you will get? So you need to put it one by one also. So any question? Alhamdulillah. So you can see this is decimal. You need to change in hexadecimal. Then you can put inside. So you pick this first, 0, 0, 0, 0, 0, 0, and add 0. So you complete your value in your offset. Any question? Try to copy all the sentences, put in your template, run in your Visual Studio. Then you can see and understand more. This one is very important, okay? Normally it's always been asked in your test until final exam. Any question? Oh, just now.
In positive and negative number in
Did you ask a question?
can you hear me?
Yes. Okay, what is your question?
How can we differentiate between positive and negative number in sign byte?
Or standby. Just now we learned it already in front. Where are we now? Okay, at the sign initial value here. Tak sampai lagi. Real number constant. You're going to see negative and positive. But normally we will put sign in the value. Similar also with the just now, the example, last example we look together. Ini dia. Okay, this one. This is sign. So you just use this, you convert it to the hexadecimal value for the negative 214 blah 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 blah. This is a sign number. Then if you convert this value to hexadecimal, you will get 80 hexadecimal. But normally for hexadecimal, we not play around with the whether it is positive or negative. That's why you will get 80 what this? At 100 at 1000, at million. 80 million. 80 billion. Million, I think. So that is the value. So normally we will just put the negative or positive. Unless you didn't put any value in front in the symbol, so it is positive. Okay?
Okay, Doctor.
In terms of converting, this one we already learned in like decimal digital logic subject, how to convert from decimal to binary, especially in terms of negative number also. We have the double precision and etc. to convert. Okay? Okay, if there is no